So I just wanted to do a few optical rotation practice. This is a concept that students typically struggle with, so I just want to make sure that we walk through a couple of examples for you guys to hopefully clear up any confusion that we might have about this. So I'm just going to work through a few problems so you can see the process and see the patterns that we do. So for this first problem, we're told that we have an enantiomer, and it clarifies that we have the positive enantiomer. Now, recall with that, we cannot determine if this is the R or S enantiomer. Plus and minus has nothing to do with the three-dimensionality or the orientation in space of these stereoisomers. It only tells you if it rotates the plane of light clockwise or counterclockwise. So I just wanted to remind you guys about that. All right, so we have a positive enantiomer of a compound that has an optical rotation of 125. So what that just told us was pure positive enantiomer has a positive 125, ooh, that's a 9, that's not a 5, 125 degree optical rotation. I have a mixture of enantiomers that gave an optical rotation of 100. Okay, so I have a mixture of plus and minus here, that would be 100, and it wants to know the composition. So how much of positive there and how much of minus is there? So in order to solve this, we need to determine the EE of the solution, or the enantiomeric excess. What this equation is going to tell us is how much more of one enantiomer there is over the other. It doesn't tell us exactly how much of our predominating enantiomer is going to be. It just tells you how much more you have. So if we think about the idea, we know that if we have a 50-50 mixture of enantiomers, we should have an optical rotation of 0 for this, because one enantiomer will rotate plane of light in one direction, whether that be clockwise or counterclockwise, and then the other enantiomer will rotate in the opposite direction of the first. So if I have one enantiomer, let's say that goes clockwise, one goes counterclockwise, if you have equal amounts, well, they're just going to cancel each other out. So that's how we have what we say a racemic mixture would give you a 0 optical rotation. All right, so again, we have pure here is 125 degrees, and then we have a mixture of plus minus at 100 degrees. So my EE that I'm going to determine, to calculate EE, you're going to have the specific rotation, specific rotation. I say rotation of your mixture, so that's having both, and you divide by the specific rotation of the pure enantiomer. So sometimes and then you multiply by 100%. So sometimes you might hear me say dirty divided by pure, the mixture divided by the pure, the reference number. And you'd have to be told the reference of the pure. I imagine that you guys don't typically know what the optical rotation of pure compounds are. It's definitely not something I would know. So that would have to be given to you in the problem. Okay. So let's go ahead and start solving the EE. So if I want to find my percentage of EE, I would take my mixture optical rotation, divide by the pure. So one thing I can say about this is because our mixture has a positive value, that does tell me there's more of the positive enantiomer in the sample. But how much more, I can't say exactly without doing the calculation. So what I'm getting for this EE, let's see, 100 divided by 125 times 100. Okay, so I'm getting that I have 80% EE of this mixture. What that 80% says is that this is how much more of the positive exists over the negative. Okay. So this is how much of enantiomer, of the positive enantiomer is not being canceled out. This is what's giving us that positive 100. That does not mean this is the total amount of the positive, right? Because if it's a mixture, there's still a little bit being canceled because you have both present in the solution. This, again, is what is not being canceled out. So in order to find the amount that is, we need to figure out what the rest of the mixture is. Well, if I'm talking about percentage, I can figure out the rest of the composition of it by subtracting from 100. So that means I'm going to get 20%. This 20% represents the enantiomers that are canceling each other. I don't think I spelled that right. Good Lord. Okay. I'm very doubtful. Okay. Canceling each other. All right. So this is how much that is not being canceled. This is how much that is being canceled. If that's being canceled out, that means that this is racemic, because the only way I can perfectly cancel out is if I have equal amounts of both of those there. So in order to figure out how much of each enantiomer I have in the part that's racemic, I'm just going to divide by 2, because I only have 2 enantiomers present. Oh, that is not what that number is. So I should get 10% here. This is going to say, this tells me that I have 10% of the negative enantiomer. And then to find the total amount of positive enantiomer, I'm going to add that 10% back to the 80% of what I found from the EE equation. So that is how much positive I have. So 10% minus 90% 90% positive. So again, this 80% that we have here is what is not being canceled out. That's how much we're rotating that plane polarized light to get the 100 degrees of our optical rotation. The 20% is what is being canceled out. That's why we're not seeing a full 125, because we don't have a pure sample of the positive enantiomer. All right, hopefully that clarified some questions you might have about specific rotation.